about the ideas of combination in genes, now focusing on Punnett square and how to predict the probability of having different traits. Today's Thursday, April the 30th. Let me again present this, and that will be better for everyone. On the activity today, we will be working on Do Now. Next slide. Do Now on SchoolNet, and this is the passcode. Please do it. The same essential question for the entire unit and the North Carolina standards. Well, the class today I want to start with this question. How does the combination of parent alleles affect offspring? So last class we talked about the information that these letters bring in different alleles of the same gene. We learned that when they have an uppercase letter, it's a dominance. It's a dominant trait. It codes for a dominant trait. When it has a lowercase letter, it codes for a recessive trait. And this is a heterozygous gene, which is different. When you have both uppercase, we call homozygous. When you have both lowercase, we call homozygous as well. Homozygous recessive, homozygous dominant, heterozygous only. Well, in this case, I can see that this gene that codes for the color of your eyes, if it's a heterozygous father coding for brown eyes, of course, because brown is dominant over blue, and the mother is heterozygous as well, and he expressed the brown color. Well, when you mix up this information, there are many probabilities. I can donate, this father can donate the uppercase B or the lowercase b. If donates the uppercase B and mom donates the uppercase B, we make a upper B, upper B. If dad donates uppercase B and mom donates the lowercase b, we have upper B, lower b. Now, if the dad donates the lowercase b and mom donates the uppercase b, we have also upper B, lower b. And the other chance is that daddy donate the lowercase b and mom also donate the lowercase b. And then we have recessive, homozygous recessive, and that's the only way it can show a blue eye color. So it's going to be 1 out of 4 chances that you have, if both parents are heterozygous, 1 of 4 chances that you have to express the blue color, or 25%. 75% you will be expressed are the chances for you to express brown color. So this is how you're going to learn how to check these, and the Punnett square is used to show how these probability for the genes work. A Punnett square is used to illustrate how parents' alleles might combine in offspring. So what I have is, for example, I have this blue chicken with the blue chicken. Well, however, they're not homozygous dominant. They are both heterozygous. So one allele I have here on top for uppercase B and lower B, and the other parent we go for upper B, lower B. So you basically describe the information, the genetic information, the genotype of the parents on the side and on top, and then you check in the middle what are the probabilities, right? So when it's dominant B and B, you're gonna have this type of chicken. When it's heterozygous, you're gonna have this type of chicken, and when it's recessive lowercase b's, you have the other type of chicken. Let's take a better look at this. So the Punnett square, you can check actually on this YouTube video also with more information. But just like I told you, all you have to do is to describe the parent alleles on the side and the other parent allele on top. And then you basically mix them up. If I donate big R with big R, we have both uppercase R's. Big R with small r, I have upper R, lower R. Small r with big R, We have big and small r. We usually bring the uppercase letter first. It doesn't matter. And the last one is bringing small r with small r. We're going to have lowercase r for this genotype, whatever it codes for. Okay? So let's look at this example. We have a father that shows double tail, and that will be combining their genes with the mother, crossing with the mother who carries double tail but shows normal tail. So the mother carries information in the genotype for double tail, but it shows normal tail. It means that normal tail is dominant um, over double tail. So what you have here, you have a heterozygous and a homozygous. And then when you cross, upper D with upper D shows double tail and its dominant carrier. Upper D and upper D again shows double tail and its dominant carrier. Well, when it's heterozygous, shows normal tail but carries double tail. And the same thing here. What percent of the offspring will have a double tail? Well, when you analyze this map, these are the chances. I'm not saying that this is a real information. These are the chances I'm predicting. So when you analyze this graph, we're gonna have 2 out of 4 squares having double tail, which is this first two. So 2 out of 4, or if you prefer, 50%. And what percent of the offspring will have a normal tail? Well, that would be also 2 out of 4, which is also 50%. So you imagine that you have half and half the chances to have double tail or normal tail. Now, we can also examine the following Punnett square, where uppercase B is dominant for brown eyes and lowercase b is recessive for blue eyes. Let's try to do this together, because I know we're not in the class. Identify the parent alleles. Where do we find the parent alleles? On top and on the side. So the alleles for Carrie is upper B, lower B, and the allele for Rusty is lower B, lower B. So these are the genotypes. For Rusty, this is the genotype. For Carrie, in the gene that expresses the color of the eye. Which parent's alleles are homozygous? Remember, homozygous is the name we give to the genotype that carries the same information. So here it brings an allele for brown and another allele for blue. So they bring different information. So this is not homozygous. This is blue and blue. So Rusty has a homozygous allele. Identify the heterozygous alleles. So these are the heterozygous alleles. Carrie is the one who brings the heterozygous allele. What percent of Rusty and Carrie's offspring will have brown eyes? Well, after you combine lower B with upper B, lower B and lower B, lower B and upper B, lower B and lower B again, well, what percent of Rusty and Carrie's offspring will have brown eyes? Brown eyes, because brown is dominant over blue, so I'll have this situation and this situation. That would be 2 out of 4, which is 50%. What percent of Rusty and Carrie's offspring will have blue eyes? Also 50%. Okay? Yeah, here are the answers. You also can check some rap for distraction and relaxation. Or if you prefer a reviewing for a video clip, you can check on this YouTube link as well. Well, now it's time for you to practice by yourself. Go to your Google Classroom, check your handout named Genotype, Phenotype, Homozygous, and Heterozygous Practice, and answer them on the Google Docs you created yesterday. Also, you have your Punnett square and combination of genes activity. You answer in the same Google Docs you have created before. And this is the code for exit ticket. Have fun, and I see you next time.